I will introduce the paper titled Text-Guided Variational Image Generation for Industrial Anomaly Detection and Segmentation. This topic is aimed at solving the anomaly detection and segmentation task through an improved image generation method. Previously, most techniques have focused on modeling the non-defective distribution to identify target defective data. Modeling the non-defective distribution fundamentally revolves around the creation of a decision boundary. Proper modeling of only non-defective data is a tough challenge and is directly related to the quantity and quality of non-defective data. If the generalization of non-defective data is overly strong, even defective instances may be misclassified as non-defective. Conversely, if non-defective diversity is too strong, it might be wrongly flagged as defective. An appropriate balance between the generalizing and diversifying of non-defective characteristics is essential. Previous reconstruction-based models, learned from non-defective data, utilize encoders to extract key features and decoders to restore them. However, the lack of diversity in non-defective data can cause these models to misidentify unusual patterns as anomalies. Collecting a diverse set of non-defective data is often impractical or expensive, especially in specific industries, and limited diversity can lead to misclassification of new non-defective patterns. Research also exists on the generation of anomaly data. However, defining representative cases of actual anomalies is complex, making accurate labeling of such data difficult. Moreover, even with generated defective data, there is a risk of overfitting. When models include defective data, they may adapt too closely to specific patterns, which can diminish their ability to generalize, especially if the defective data is sparse. These challenges highlight the necessity of ensuring both the quantity and quality of non-defective data in training robust models. Through preliminary experiments and analysis of our method, we define the specific requirements of that can effectively improve the generalization ability. We conducted a one-shot test comparative experiment based on one representative image. The performance of images with shapes similar to the original image found directly on the website was relatively higher than that of images output by commercial tools such as DALL-E and Midjourney. This can be inferred that performance was relatively higher in that elements such as the outline and angle of the original image were maintained in the web image. Additionally, as a result of a comparative experiment by generating only word, naive prompt, and generated prompts from the same model, we can see that well-generated prompts can also help improve performance. First of all, the elements of the model based on the target to be solved by the variance-aware image generator are as follows. Similar to appearance is a consistency issue, and preserving their visual variance is connected to diversity. A well-generated prompt requires a way to reduce the semantic gap between the image and the prompt. The basic direction of the model was established based on the necessary conditions. First, we developed a variance-aware image generator to generate images similar to the appearance of non-defect images while maintaining visual differences. Second, we developed a keyword-to-prompt generator to find the best prompt appropriate for the input image. Third, we developed a text-guided knowledge integrator to reduce the semantic gap. The experimental results on generalized detection using MVTech-AD dataset indicate enhanced performance across all baselines, thus verifying our model's ability to generalize. The results show an performance increase at all scenario, confirming that our framework can successfully achieve impressive performance even with a few training images. We conducted experiments on the BT-AD and MVTech Loco-AD datasets using the patch-core method in a one-shot setting. Our method significantly improved detection and segmentation performance, especially for object types in BT-AD, and consistently across all cases in MVTech Loco-AD. We can visually confirm that our method is improved over the baseline through the qualitative results of few classes. Thank you for listening to the presentation. If you have any questions about the paper, please leave your questions via email or GitHub link below and we will respond.